Hello, everyone. Welcome to our Snapshot Saturday today. My name is Lacey Fontaine. I am the program assistant here at the Charles Lindbergh House and Museum. Today, I am joined by Ali Wysopal. She works for the Minnesota Historical Society as well. A little bit of background on Ali. She holds an MS in Historic Preservation from the University of Texas at Austin, where she specialized in material conservation. Prior to starting at the Minnesota Historical Society, Ali worked with public art and sculpture as the collections assistant for landmarks at UT Austin. And then she completed a graduate conservation fellowship at the Metropolitan Museum of Art. Currently, she is a project manager with the capital planning and management team for MNHS. And Ali gets to contribute to the care of the many historic properties that we oversee throughout the state. And she worked on our ice house project. So we have a lot of, like a lot of our sites, we have a lot of historic preservation issues at our site. But our biggest concern this year was our ice house. It had moved quite a bit due to soil erosion, and you oversaw that project. So I will let you take it over and you talk about this project. And then after she's done, we'll answer any questions about historic preservation. It was a topic that came up a lot for us this summer. And I'm sure you get a lot of questions anyway about it. So if there are questions at the end, we will address them then. Otherwise, take it away, Ali.
Awesome. Thank you, Lacey. All right. So hello, everyone. My presentation today, as Lacey mentioned, will cover the scope of the Ice House Stabilization Project. Not only the treatment that was carried out, but all the preparatory work that it took to get there. A successful historic preservation project is highly collaborative. It benefits from the input of multiple professionals, from architects, engineers, conservators, archaeologists, cultural resource management specialists, historians, and even more depending on the work in question. I hope today's presentation can highlight the efforts of the many who came together to make this project a success. And if I can get to the next slide, thank you. So some background on the site and why this work was undertaken. The exact construction date of the ice house is unknown, but it is presumed to have been built around the time of the original main house in 1906, or when the home was rebuilt in 1910 following a fire. The ice house is a small wood-framed building set on a stone rubble foundation. As a functioning ice house, the dirt floor would have been dug out to store blocks of ice. Used by the Lindbergh family, it is a contributing component of the site, which is designated as a National Historic Landmark. While the appearance or the exterior of the building has been restored to a period-appropriate appearance, the interior has been modified to allow for its use as a storage shed. Previous work on the ice house has included infilling the pit and adding a concrete slab-on-grade floor, as well as adding concrete strip footing to the east foundation wall. Those already familiar with the site know that both the home and the ice house are located along the edge of a hill leading down to the Mississippi River. This hill has been experiencing erosion, including a major landslide event in 2020 that exposed the east foundation wall of the Lindbergh home, which was quickly addressed. But following that, concerns were also raised by staff who observed a sizable gap between the east foundation wall and wooden structure of the ice house. To prevent additional damage, or at the most extreme, loss of the whole building, this project was undertaken with the goal of stabilizing the ice house. To achieve this, we knew we would need to first confirm what was actually causing these conditions before a design team could develop a solution that fully addressed our concerns. Next slide. So how do we ensure our projects actually adhere to best practice to take all factors into consideration and then also provide for the long-term preservation of a site? So I wanted to provide a quick overview of the general project phases we follow at MNHS when we complete a project and how it was then applied for work at the ice house. I'll then dive into the work accomplished in each phase a little bit more after this overview. So after a need has been identified, we start with a planning phase to develop a scope of work, which is a high-level list of items to be accomplished during the project. This is the time for our team to visit the site to gather additional info and engage with stakeholders, both inside MNHS, including the site manager and maintenance staff, our archaeology department, and Native American initiatives, as well as external stakeholders. So in this case, the Fond du Lac Tribal Historic Preservation Office and the Mille Lacs Band of Ojibwe Tribal Historic Preservation Office, or TIPO. And by engaging with stakeholders prior to starting design work, our aim is to ensure that the full significance of a site is being considered and any risks identified early on. As was the case on this project, this phase can also include assessment work to better understand the condition and structural concerns. Once the project scope is finalized, we enter the design phase. So that's that second dot there. Here we engage an outside firm to develop drawings and specifications that will guide the construction work. An important note is that engagement with external parties doesn't necessarily end in the planning phase, but instead continues through the entirety of a project. So for the Ice House project, the construction drawings were shared with the Fond du Lac and Mille Lacs Band of Ojibwe Tippos, the Minnesota State Historic Preservation Office, or SHPO, and the National Park Service for their review prior to moving into the construction phase. So once we're in the construction phase, here work on the Ice House was split into two components due to limitations I'll touch on later, and was completed in the spring of last year. Which brings us to our final phase, which we are in right now for the Ice House project, which is maintenance and monitoring. So our connection to the project doesn't necessarily stop as soon as construction is wrapped. We ask our design teams to provide maintenance guidelines to be used by the site staff to monitor the work performed. And we'll review what this looked like specifically for the Ice House in a later slide. Next slide. So backing up to that pre-design phase where we start, to find an appropriate solution, we had several questions we needed answers to. What were the conditions we needed to address? We knew that there were gaps between the foundation wall and the wooden structure, and cracks in masonry were visible. But did this movement translate through the rest of the building? Was there damage to the walls or the roof? And what was causing these conditions? We could assume movement was linked to the eroding hillside, but this needed to be confirmed to rule out other possible culprits such as frost heave and to ensure our selected treatment addressed the correct causes. We also wanted to understand how active the movement was. So here I've included some images on the right of our documentation during that pre-design phase, and you can see the crack that I'm talking about on the lower right image. So you see that crack between the rubble stone foundation and then that wood structure above. And then you can also see on the top right corner, a couple of our crack monitors that were installed, and I'll talk about what those were doing later. But just so you have some reference, those are those kind of vertical wood blocks with the plastic white piece in between. Another question we needed answers to: what treatment options were available? We asked our design team to present options to then be discussed internally. As part of the selection process, we considered not just the longevity of the solution, but its impact on the building and surrounding environment. This is one of the reasons why it is so important to engage with all stakeholders earlier and at regular intervals to ensure that all possible adverse effects are being identified and mitigated. And finally, we have to take into consideration the cost and timeline of the work. We of course have budgets for projects, but we also need to consider how this work may impact the site. Will it require closing all or a portion of the site to carry out the work, and for how long? Next slide. So to answer all of these many questions, MNHS contracted Matson McDonald Young structural engineers to perform a condition assessment of the building and provide structural recommendations. During this work, they reviewed data collected via crack monitors, which we kind of mentioned, but upper left corner is going to be a detailed image of what that looks like. And these crack monitors showed the foundation's pattern of movement. Our engineers also examined the interior of the building for additional damage and compiled their treatment recommendations into a single report. Next slide. I've included 3 images from that report here. 2 graphs, so upper right and across the lower. These graphs translate data gathered from the crack monitors, which show some bidirectional movement, but an overall trend of the foundation moving away from that wood frame, as we suspected. And a drawing that captures the observed conditions, the gap above the east foundation wall and vertical cracks along the corners of the north and south wall are shown in that upper left image. From their work, Matson McDonald Young were able to eliminate concerns of frost heave and material failure, which is great. and instead identified soil erosion as the cause of the movement. They further determined that while a majority of the movement occurred in the past, the east foundation wall was still sinking at an approximate rate of 2 millimeters per month, and that the vertical cracks were a sympathetic response to the displacement of the east wall. Thankfully, the remainder of the foundation and wood building were found to be in stable and good condition. Next slide. Finally, as part of their condition assessment, Matson McDonald Young provided the following possible solutions. Option 1, in the upper left corner, was the installation of helical piles, which are essentially metal piers, so picture like a robust pipe with built-in angled fins wrapping around it to create what is essentially a very large screw that can then be driven into the ground further than your footing. It was proposed that these be installed along that east foundation wall with a bracket then on top to kind of catch that footing, and then very carefully adjust the bracket to lift the wall back into plane. And I'll have a picture that kind of goes into a little bit more detail of what that is later. But once back in alignment and stable, any remaining cracks in the foundation would then be repaired. The second option was the installation of riprap in the area adjacent to the east foundation to protect the soil from water runoff. So that's what's pictured in that lower left image. And then the remaining two options, 1, regrade the whole hillside, as you can see in the upper right, or 2, or I guess 4, install terraced retaining walls, as you see in the lower right. So while the two options on the right would address the known hillside erosion, they would also result in extensive ground disturbance. Beyond the site's significance as Charles Lindbergh's childhood home, the area holds important archaeological data that would be put at risk should either of these two options be pursued. Instead, a combination of helical piles and ground protection was selected as the least invasive option that would prevent future movement by stabilizing the foundation and mitigating the negative effects of rain runoff from the ice house roof. Next slide. All right, so to ensure that the helical piles could be installed at an effective depth, which would be a point where they too would not be affected by the shifting hillside, we brought in Braun Intertech to perform soil boring analysis. Very exciting. During this work, a boring rig was driven onto the site to drill a hole and collect core samples that were later analyzed in a lab. After the data was interpreted, it was used by engineers to confirm feasibility of the helical piles. So that whole report is basically summarized in the image on the right, which shows their findings for each kind of layer of core sampling depth. As this work did involve ground disturbance, our archaeological department was brought to select the area for testing as well as monitor the work alongside staff from the Mille Lacs Band of Ojibwe Tippo. As part of this work, the MNHS and Mille Lacs Band of Ojibwe archaeologists observed the soil being brought up by the rig, and if they had deemed necessary, would have halted that work. So you can see on the upper left corner, we have our teams out there selecting where we want to dig, and then they are actually monitoring in that lower left photo, kind of sifting through, making sure that we're not bringing up anything of concern. Next slide. All right, with all this data in hand, we were able to move into the design phase. For this project, Matson McDonald Young, with assistance from McDonald and Mack Architects, first developed a draft drawing set that was reviewed internally at MNHS. This is an opportunity for the team to make any changes before receiving the final construction drawings. So in this case, we wanted to make sure it was clearly communicated to contractors where heavy machinery was allowed to be within the site. So the image on the top left shows that determined access path. And then the image on the top right lists requirements for ground disturbance or ground protection, and the designated staging area. We also wanted to make sure the location and depth of ground disturbing work was clearly defined, and the new material being introduced, primarily the mortar for those mortar repairs, was compatible. As mentioned earlier, the construction documents were then submitted for regulatory review. In addition to continuing to keep the Fond du Lac and Mille Lacs Band of Ojibwe Tippos informed with an invite to participate in monitoring for the construction work. All right, next slide. Phase one of the construction work took place in the winter of 2023 and involved installing the helical piles and extended ground protection, or riprap, along the east hillside. I've included this detailed section from the construction drawings that shows in a little bit clearer detail, I think, how the helical piles were installed and attached to an L plate that would have run along the length of the concrete footing to then distribute that weight that the brackets are going to place on the footing and prevent stress cracks in the mortar from an uneven pressure. It also shows a note on the ground protection, placement of polypropylene sheets or sheet, and reuse of the existing riprap plus some additional material to extend that area of coverage. Care was also taken to maintain a positive slope away from their foundation, as you can see in that note, slope to drain. The picture on the right shows the installation of one of those helical piles. Due to the risk of ground disturbance and unstable soil on the hillside, no machinery was allowed on the east side of the building. Instead, our contractor for this work, Foundation Support Systems, used a bobcat fit with a drill to reach around from the north and south sides of the building and install these piles. You can also see our trusty archaeology and NAI team members bundled up and monitoring the work in the left corner. We prioritize getting these stabilizing measures in place before another freeze-thaw cycle, which saw us working at the site in December. All right, next slide. All right, here we have some very fun before and after photos of that gap between the foundation and the wood structure. So you can see the gap almost fully disappeared in the north corner and was diminished by about half on the south corner. So let me orient myself here. So the top two right photos are going to be our north corner. You can see before on the left and after on the right. The cracks almost disappeared. And then our south corner is going to be on the bottom. So the left is before and the right is after. So you can still see some gappage there. This was as far as we were able to really safely lift the foundation, which is why there is still a gap present on the south. And it was determined that the remaining gap would be addressed along with the planned mortar repairs in the spring. And then this final image on the left shows the completed phase one with riprap installed. Next slide. Due to temperature requirements for installing mortar, phase two, which were those mortar repairs, needed to wait until the spring when our contractor returned to the site to repair cracks in the rubble foundation. On the left, we have the south corner where there, again, remember there was that larger gap. And then on the right, we have the north corner. You can see this is after any repairs for the mortar were made. All right, next. This brings us to the final step of the project, receiving guidance on maintaining the work just performed. What is included and how those guidelines are received varies by project. In this case, it was recommended that we reinstall the crack monitors and continue to monitor them using the tracking sheet pictured in the center image. Kayla and her team have very graciously taken on this work, and the capital planning team will review the data annually to ensure the piles continue to perform. Our capital planning department also performs annual condition surveys of each site to better inform future preservation projects. So as an example of something we continue to track, it's of course the hillside at Lindbergh, as erosion continues to be a present risk. So on the right, we have that picture of the hillside that we monitor. All right, next slide. Thank you all for tuning into today's talk. A really big thank you to Kayla and all current and former Lindbergh site staff, including the wonderful maintenance tech, Rory, as well as my colleagues in archaeology, Native American initiatives, and capital planning team members who laid the groundwork for this project. This work would not have been possible with all their contributions. So thank you.
Awesome. Thank you so much, Ali, for coming and talking about this. It is certainly a lot of questions that we get from our guests about how how we prioritize our historic properties, and how do we decide what to fix first, and the condition of our properties. I'm sure it's not unique to our site. A lot of our sites get questions like this. I'm wondering if you could speak a little bit to the legislative process of getting funding for these projects and how people can help bring attention, or help with these projects as people who care about these historic sites.
Sure. So it's a bit of a multi-leveled answer, and some of it is going to be a little beyond my position as a project manager, but I will do my best. So to backtrack a little bit, the projects that our capital planning department undertakes are bond funded typically, and we call them asset preservation projects. So the legislative cycle goes through, and every other year we hope to receive bond funding. I believe we are entering another cycle here, so hopefully we get some more funding. But that's kind of where our budgets can come from. So we are slightly restricted in what we can tackle based on what kind of funding we get from the state. Unfortunately, our funds are not limitless. From there, once we get our funding amounts, we, like I mentioned, go through and we are making surveys ideally of all of our sites every year. So not the project managers, but the director of capital planning and management is in charge of taking all that data back. What are we observing from our different sites, and coming up with a list of here's our most pressing projects that we really need to tackle for various reasons. And then from there, we can kind of start our planning phase, which I kind of walked through those different phases of the projects. I will say that we kind of flew through this presentation, but asset preservation projects, each phase can take months, which is why it can take us a while from identifying a need to actually being able to move forward with that construction work. And there's lots of different things at play with those timelines. But one of the items, and I think the ice house is a really good example of that, is that we do need to kind of gather data to make sure that our treatment is actually appropriate in addressing the root concerns. And that always takes a little bit of time too. You never want to jump into doing the work without knowing what you actually need to address. Yeah. One of the many reasons why historic preservation projects can differ a little bit from a regular construction project.
Mm-hmm. Yeah, thank you. I have a better understanding of it too, and it's our guests. Over the summer, we heard a lot about, people wanted to know about the ice house project because they could clearly see the gaps in the ground disturbance too, where the work was done. So they were genuinely curious about the process of historic preservation, why it does take so long to get these projects accomplished, and also where that funding actually comes from, and stuff like that. So I will be better prepared to answer those questions moving into our season this summer. I have no questions from anybody on Facebook or YouTube, but if some pop up, I can always email you and hopefully get them a response as well. But thank you for joining us today and helping us explain this process a little bit more, and the challenges that historic preservation will be going into in the future. We have a lot going on now, so a lot of projects. I'm sure we're incredibly busy all the time. So thank you so much for taking time out of your Saturday to come in and talk to the public about the ice house and what that process looks like.
Yeah, well, thank you for being wonderful partners in this project. It truly makes all the difference. So I'm happy to do it.
Awesome. Thank you.
Yeah, thank you.